Scientists find that the moon is periodically showered with oxygen ions from our Earth. Now, this recent discovery from water molecules coming from the solar system, the solar wind, together now hydrogen, creating water on the moon, on asteroids, by the hydrogen that's given off by solar wind. So if you have a hydrogen from the solar wind, the oxygen ions from Earth, what does that mean for the area of our solar system? Moon found to be periodically showered with oxygen ions from the Earth. Scientists with affiliations with Japan examined data from the country's moon-orbiting Cayuga spacecraft, and they found evidence of oxygen from Earth's atmosphere making its way to the surface of our moon for a few days every month. According to the paper published in Nature Astronomy, they've known for some time the moon is constantly bombarded with particles from the solar wind, and also known that once a month, as Earth is positioned between the sun and the moon is protected from the solar wind. In this new effort, researchers described evidence of oxygen ion transport from Earth's outer atmosphere to the lunar surface during this short period of time. Before this research has shown that oxygen atoms become ionized in Earth's upper atmosphere when they're struck by ultraviolet light. Sometimes this causes them to speed up to the point that they break away from the atmosphere and move into what is known as the magnetosphere, a cocoon that surrounds our planet, stretching like a flag away from the direction of the sun due to the solar wind. So far, in fact, it covers the moon for 5 days every lunar cycle, causing the moon to be bombarded with a variety of ions. The data from Cayuga suggests that some of those ions are oxygen. The researchers found that approximately 26,000 oxygen ions per second hit every square centimeter of the moon's surface during this deluge. Because the moon is protected from the solar wind by the Earth, when the increase in oxygen ions was recorded, the researchers are confident they come from the Earth. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So the scientists believe that these oxygen ions come from the Earth. Adding even more credence to the items were found to be moving slower than those that normally arrive via the solar wind. And also they said prior research found lunar soil samples containing some degree of oxygen-17 and oxygen-18 isotopes, which are not typically found in space, but are found in the ozone layer covering our Earth. And the abstract says, for 5 days of each lunar orbit, the moon is shielded from solar wind bombardment by Earth's magnetosphere, which is filled with terrestrial ions. Although the possibility of the presence of terrestrial nitrogen and noble gases in lunar soil has been discussed based on their isotopic composition, complicated oxygen isotope fractionation in lunar metal 2-3, particularly the provenance of a 16 oxygen poor component, remains an enigma. And here we report observations from the Japanese spacecraft Cayuga of significant numbers of 1 to 10 volts, oxygen ions, seen only when the moon was in the Earth's plasma sheet. Considering the penetration depth into metal of oxygen ions with such energy, the 16 oxygen poor mass independent fractionation of the Earth's upper atmosphere, we conclude that biogenetic terrestrial oxygen has been transported to the moon by the Earth's wind and implanted into the surface of the lunar regolith at around tens of nanometers in depth. We suggest the possibility that the Earth's atmosphere of billions of years ago may be preserved on the present-day lunar surface. This is from Nature Astronomy abstract on phys.org. But we also have another event going on. Earth's atmosphere stretches out to the moon and beyond. This is by Claudia Mignon, American Geophysical Union. The gaseous layer that wraps around Earth reaches up to 630,000 kilometers away, or 50 times the diameter of our planet, according to a new study based on observations by NASA Solar Heliospheric Observatory SOHO and ESA, published in Geophysical Research. The moon flies through Earth's atmosphere, says Igor Bailyukin of Russia's Space Research Institute. He's the lead author of the paper, saying we were not aware of it until we dusted off observations made over 2 decades ago by SOHO spacecraft. The moon flies through Earth's atmosphere. Where our atmosphere merges into outer space, there is a cloud of hydrogen atoms called geocorona. One of the spacecraft instruments, SWAN, uses sensitive sensors to trace the hydrogen signature and precisely detect how far the very outskirts of the geocorona are. These observations could be done only at certain times of the year, when the Earth and its geocorona came into view for SWAN. For planets with hydrogen in their exospheres, water vapor is often seen closer to their surface. That is the case for Earth, Mars, and Venus. Now, the Jean-Luc Bertois explains, he's the co-author of the paper, says, this is especially interesting when looking for planets with potential reservoirs of water beyond our solar system. The first telescope on the moon, placed by Apollo 16 astronauts in 1972, captured an evocative image of a geocorona surrounding the Earth and glowing brightly in ultraviolet light. Jean-Luc said at the time, the astronauts on the lunar surface did not know that they were actually embedded in the outskirts of the geocorona. The cloud of hydrogen, the sun interacts with hydrogen atoms through a particular wavelength of ultraviolet light called Lyman alpha, which is the atoms can both absorb and emit. Since this type of light is absorbed by Earth's atmosphere, it can only be observed from space. And thanks to its hydrogen absorption cell, the SWAN instrument could selectively measure the Lyman alpha light from the geocorona and discard hydrogen atoms further out in interplanetary space. The new study revealed that sunlight compressed hydrogen atoms into the geocorona on Earth's day side and also produced a region of enhanced density on the night side. The denser day side region of hydrogen is still rather sparse, with just 70 atoms per cubic centimeter at 60,000 kilometers above Earth's surface and at about 0.2 atoms at the moon's distance. Igor says on Earth, we would call it a vacuum. So this extra source of hydrogen is not significant enough to facilitate space exploration. The good news is that these particles do not pose any threat for space travelers on future crewed missions orbiting the moon. Jean-Luc Bertois says there is also ultraviolet radiation associated to the geocorona as the hydrogen atoms scatter sunlight in all directions, but the impact on astronauts in lunar orbit would be negligible compared to the main source of radiation, which is the sun. On the downside, the Earth's geocorona could interfere with future astronomical observations performed in the vicinity of the moon. Space telescopes observing the sky in ultraviolet wavelengths to study the chemical composition of stars and galaxies would need to take this into account. The power of archives. Launched in December 1995, the SOHO Space Observatory has been studying the sun from its deep core to the outer corona and the solar wind for over 2 decades. The satellite orbits around the first Lagrange point, L1, some 1.5 million kilometers from Earth, towards the sun. This location is a good vantage point to observe the geocorona from outside. SOHO's SWAN instrument imaged Earth and its extended atmosphere on 3 occasions between 1996 and 1998. Jean-Luc and Igor's research team in Russia decided to retrieve this data set from archives for further analysis. This unique view of the whole geocorona, as seen from SOHO, are shedding new light on Earth's atmosphere. Data archived many years ago can often be exploited for new science, says Bernard Fleck, ESA SOHO project scientist. This discovery highlights the value of data collected over 20 years ago and the exceptional performance of SOHO. This is on by American Geophysical Union on phys.org. Please leave your comments and thank you for your support.